quick demonstration on how in P21 we can use document links to manage inspection reports, to handle inspection in Taiwan, the US, Canada, Mexico, and Finland. So if we start off in discuss today, I'm going to talk about where we can download the linked inspection reports from P21, how we're going to review them, we're going to complete them when we do inspection, how we're going to save them so we have a permanent record of the inspection, and then if there's any issue with the inspection report, how we're going to update it, whether it's a print revision, whether there's an omission, in how we're inspecting it, if there's a non-conformance, if there's a new approved vendor for that part. But let's start off in P21. Okay, start off with item master inquiry, so you can hit F2 or you can go through the pull down. Part number that we're going to inspect today, let's say it's come in on a truck, it's come in on a container. You can use the RP digit number, or you can use the SBS part number that they're cross-referenced. This part is a pretty precise cyclical part wheel stud that's used on the SSV down in Mexico. We hit document links. Up see that there's a document link for this part number. In this case, we have a document link for an inspection report. You might have a print, you might have a cert or something else, but we want to look today at the inspection report. And over in the link path, we have a hypertext hyperlink to the actual inspection report that we want to look at. It's on a drive called TSO3 in a folder, document links, in a folder, inspection report templates. So right-click, view to maintenance link, and go to Excel, open up this. So this is basically, let me pull back. What we have here is a blank inspection report. We don't have anything measured, anything of the features done. The first thing that you're going to want to do, pull up the inspection report, review what the actual inspection report. So for this part, it's a PPAP level 3 part. The C is critical, so there's a safety concern with this part. PPAP level 3 part, we've had to have the vendor approved with the customer BRP, and in this case, the approved manufacturer is Ben Yen. If another manufacturer who was approved to make this part, their name will be here as well. So the process will be making sure that the parts we're receiving are from this manufacturer, and if they're not, we need to put those parts into the script until we can submit the PPAP submission and get it approved by the customer. It's in the top left corner here. We have a history of non-conformances with this part. It's like a couple of years, but this is kind of make you start thinking, make you start focusing on what's gone wrong with this part before, either on previous inspections or a customer complaint, so that you can give them attention moving forward. So with this part, we've had a history of burrs on the internal thread of the part. So when you start inspecting this part, you know, we're going to really look at that feature. We're going to increase the sample size just to make sure that the issue has been overcome and it's not going to be repeated. We don't want to have the same customer complaint on the same part time and time again. In the top right of every inspection report, you're going to find either a print, or you're going to find a standard, or you're going to find a catalog page, and sometimes you're going to find two of those things actually embedded into the worksheet. So if you double click that file, it's going to open up the PDF and it open up the print. As I say, it might be the DIN standard, the ISO standard, it might be a catalog page, but However, whatever however we're going to inspect this part, the control document will be embedded in that part. So this is one of the most complex parts that we inspect. A lot of dimensions, a lot of features, but one of the things that you will want to review is what revision this is. This drawing is revision D. If we look at the blank inspection report, it's referencing the print number and it's referencing the Rev D. So that's the embedded file is consistent with the design revision that we're going to check. And also, if we look at P21 and with criteria, we see that the part number is currently at Rev D. Part, the draw, and the P21 description all agree. If P21 was referencing Rev E, Rev F, we would potentially have a problem. We'd have to make sure that we have the correct drawing and to see what's changed between the revisions of this inspection report and what you're going to inspect. So we have the part number that we're going to be looking at, the description, the extended description, all coming from P21. Another thing that you're going to want to review is this, is on the sheet 3, we have a picture of retained conforming parts on calibrated paper. Typically, this is going to be a picture from the PPAP submission, and the parts that you're going to be inspecting should look like this. So, they should have the same features. From the calibrated paper, they should be the same kind of size. They should have the same plating condition. They should be free of burrs. The parts should look like the pictures. So this is a good place to just review and make sure what we have is the correct part based on what P21 does. After we've reviewed the PPAP level, the print, the non-conformance, the pictures, we're ready to actually start doing the inspection. So we start off entering the lot number. We receive the parts. So in this case, we start off with number that P21 is assigned because we want to capture that in the inspection report. We're going to know what purchase order we ordered this part from. This is another way that we can cross-reference the part. Fill out those two blocks. You get your name, who inspected it, date that you inspected it at the same time. And as I said before, this is important. You're going to want to see who the actual manufacturer of this part is that you're inspecting. And it's a PPAP level 3 part. It should be one of the approved vendors. In this case, it is Ben Yem. It is possible that you could get parts that aren't approved, but then you want to put those parts aside, put them in quarantine, because there must be a PPAP that's due to the customer to get those materials approved. Okay, now the first two features we typically inspect are that the part is free of burrs, both and on the threads. So this is a simple pass-fail. You're going to look at the pictures, you're going to look at the parts, you're going to look under a microscope, and you're going to do a size of 12, and hopefully everything is going to pass. The material, 12.9 grade, and it's mechanically trivalent. You want to check on the material search to verify that it is property class 12.9. If you have a hardness tester, you want to check that. Mechanical plating, you know what that looks like, and you'll see the documentation that supports that. So again, that's a simple pass-fail. And we get those 12 pieces. In this part, it doesn't have a head stamping, but on other parts, you have property class or grade stamped on the head. Then we get into the features that are actually have a dimensionally check, and all of these features are driven from the prints in Rev D. So if you don't know where the head diameter is, you can always open up the print and verify what I mean by head diameter. So in this case, looking at 15 plus or minus 0.3. So it's this feature here. So we're looking at the body of the head. So if there's a language issue, you can verify what it is. More often than not, you're going to know exactly what these terms mean and what the calculations are. So the tier is min 14.7, max of 15.3. So my caliper, I'm going to get the measurements. If you have the USB connection, you can just press the buttons to get the measurements. You're going to show the information. And what is, if numbers here are between the min and max, I'm going to go to a pass. The conditional formatting is going to change to pass. To do all of those measurements. Now, if you record something that's out of spec, so here 15.35 is greater than 15.3, will fail. That should be indicated to say, oh, okay, did I make an error when I measured this? Do I need to remeasure it and make it more consistent? For the sake of speed, what I'm going to do is I'm just going to cut and paste a previous inspection of this part into the just to speed along the process. So you're going to look at the 12 samples that you have and each of these features and make sure that they're pass. You know, they're either the feature is a pass-fail. It's between the min and max. In the case of a part which only has a max, you know, obviously you want to make sure that your measurements are less than the min that they're passing. And what you have over here is we have 6 different statistical measurements that we're taking. In addition to the tolerance that we're recording of the min of 14.7 and the max of 15.3, when here, and this is all automatic, that the minimum number that I actually recorded with a caliper was 14.89, and the maximum measurement was 14.92. So they were very consistent numbers. You know, there was only a 0.04 millimeter range. So my CP and CPK, which is kind of process control and the process control index, these numbers are very high. I always want these numbers to be above 1. This kind of shows how accurately the part was manufactured and whether the features measure between the upper and the lower tolerance. We have a deviation and we have mean. But as I say, these are all automatically calculated. You don't have to worry about it. Here, if it's between a max, it will automatically produce a pass if your measurements are accurate. And you're going to have to go back and you're going to have to look at the features where you had to manually input the data and verify that everything is good. So here we have the number of serrations, everything was 17, so I'm going to hit pass on that one. Everything was good on that, so pass. This, on the internal thread, this is what we noted before in terms of the history of the part of the non-conformance, that we issues with burrs and glass beads, including on the internal thread. So the DMR note, we actually do a sample size of 100 for this one feature, and everything passed. So here I'm just going to manually enter pass. Again, pass. Pass. So if everything is passing, everything looks good. This is automatically going to go green. It's going to say accepted, and it's going to automatically put my signature there that I've approved everything and everything looks good. If we have an issue, when it was measured inaccurately, we get the failed and changed to rejected. Where is that? Okay, and it will turn red. In this case, everything checked out, so we're going to have that as accepted. Okay, so we verified that everything is conforming based on the inspection plan that we have. What we can do is we can look at some of the statistical analysis of the features that we measured. So here with the head diameter, as I said, we had a very narrow spread of the minimum dimension that we measured, which is 4.89 and 14.92 is the max. Of those 12 parts, it's a very small spread. This is the minimum tolerance. This is the maximum tolerance. So this is very much under control. So for this feature, we're in a green box. It looks like the manufacturer did a very good job. With the feature here on the head height, you see there's a red box here, for which we have an issue. That based on our 12 measurements, the probability that a part is going to be higher than the maximum dimension is 3.8%. So that bell curve isn't really in the middle between the min and max. It's more on the high end. We look at head height, how we measured it. All dimensions here are conforming. They're all between 20.9 and 21.1. Higher range, we're measuring 21.09, 21.06, 21.07. So that we have a CP and a process control of 1.24 and a CPK of less than 1 of 0.59. Even though we verified everything is conforming, it gives a little bit of a pause that if we looked at the entire lot, whether we would find it a non-conformance or not. So it still has, but what I probably want to do is maybe come back to this part and maybe just increase our sampling, just to be satisfied that if we did another 3 or 4 pieces, that it's still within the min and max, and verify that everything is conforming. So when we review these, the statistical analysis, it just tells us, based on measurements, how everything looked. And as I say, the box will turn red if it doesn't meet statistically the 2% rule. But it also looks pretty good here. The graphs don't work very well when you only have a maximum and not a minimum. But here we might want to look at flange thickness. Statistically, it's saying about 5% of the parts are going to be oversized. The 12 parts that we measured were all conforming. We might want to go back and measure those. Flange thickness is something that's difficult to measure, so I suspect that was a measuring issue. Say with the chamfer diameter, very difficult to measure, but it looks like the majority of our measurements are kind of on the lower end of the tolerance. So it's saying statistically, based on the standard deviation, that 7.3% of the lot could be below the min. So you might want to go back and increase your sampling plan just for those features to be satisfied if they're important features. Daniel in Taiwan, he often will take a picture of the part that he's inspecting. He will cut and paste it into the Pictures tab. So we have a picture of the retained samples, a picture of the part that he's inspected, and he will scan and cut and paste in the factory inspection reports and the material certs, so that when we review these inspection reports in light operation, we can just verify the managed documentation and the pictures are the same as the part that we're inspecting. Now we've gone from the blank inspection report to the completed inspection record. We need to save it for future review. So I have to be very careful here. We're going to go File, Save As. We want to save this file in this location. This location here is where the blank inspect template lives that P21 is referencing. So we go to the inspection drive, reports, and the format is always the same. It's going to be the SBS part number. In this case, it looks like the BRP part number, but the SBS part number is the 9-digit number RA. I get rid of inspection template. Enter the date of inspection, and we're going to use the US method, which is month, day, year. I'm going to enter the lot number. 1, 2, 3, 4, 5 in this exercise. And we want to put the location that this inspection happened. So for Daniel in Taiwan, he's going to be putting TW. Inspection is happening here in Agawam. It's going to be US. If it's in Valcor, we're going to use VA. It's Abbott in Juarez, it's going to be Mexico. If it's Finland, it's going to be RA, Rovamini. This is important because we're creating a huge library of all these inspection reports, and we want to be able to sort to the date that it was inspected, because we're going to have a lot of these inspection reports for this part. So we want to see what the date we inspected it was, what the lot number is. If there's a customer complaint, we can quickly find what the lot number is, and we can see who originally did the inspection report. So we've got to be consistent in the formatting of this, and as I say, it goes into the iDrive inspection and then into the folder inspection reports. We're going to save, and that's it. We have a permanent record of my inspection of this part on this date, and if there's any issues in the future, we can pull it up and we can review what happened. The only thing that we need to talk about is if to modify the blank inspection report. I can open up it again. If I here click View Item Maintenance, up it comes. I'm going to need to make sure that this is a living document. So a number of things could happen, making us need to change and adapt this inspection report. You might get a manufacturer approved for this part. So we might have to add the new manufacturer, so people know EPS is an approved vendor for this part. Maybe we have a non-conformance on today. Chamfer was undersized. So the next time somebody inspects this part, they know to look for both burrs on the internal thread and on the chamfer. Perhaps the drawing is going to get updated, so we might go to revision E. So that E, the description of the part has changed, so that goes to E, and then we place this drawing. We're going to embed the new revision. Perhaps we want to add another feature. We discovered that the chamfer is an important measurement, so we're saying we're going to measure the chamfer. And if we're not inspecting that already, let's look at that drawing. So the requirements for this part are 30-degree angle. That should be plus or minus 1 degree. Yep, plus or minus 1 degree. 29 max 31. I'm going to measure that with an optical comparator. I'll just put it on the drawing for a pass-fail. So we can make all these revisions blank inspection report. I'm going to hit Save As. I don't want to save it into the document links inspection report exactly where this file lives at the moment. Keep it the same file name. I'm going to hit Save. It says it all exists. We're going to overwrite it. I'm going to Excel. Back to this part now. Hit Doc Links. Right-click, View Item Maintenance Link. It's come with all those revisions that I've made. So this is how we're going to maintain that this is a living document. Primarily, the changes are going to happen here in the US when we get a new PPAP approved, when we get a new print, but we do have the option that if somebody prefers doing something different on the inspection report or feels that they add a little bit more detail to the non-conformance history, there is that opportunity to make those edits. But just any edits that you're making are going to be part of the living document. So it has to be correct. It has to be accurate. So we go back to what we did. We've looked at we download linked inspection reports on P21. We go item master inquiry. We put in the part number, either the SBS part number or the BRP part number. We go document links, and then we go to link path, right-click, view item maintenance links. That opens up the Excel spreadsheet. We talk about how we review. We look at the who the approved PPAP manufacturers are. We look at the non-conformance history. We look at the prints. We look at pictures. So that's how we review that blank inspection report. We do the inspection based on the sample size that's specified. We determine whether each feature is a pass or fail. Everything should be a pass. We go statistical analysis on sheet 2 to see that even though all the features are passing, which features are suspect. We talked about how we save the inspection reports and make sure that they go into the inspection reports drive, and then we talked about updating the linked inspection reports. Okay. Any questions, just let me know. Thank you.
What? Listen. Well done.
Have you been out there for the last 26 minutes?
He coerced me to do it.
You did. You've been talking for 26 minutes?
No, actually, we just were recording on it.